What if everything we thought we knew about the fundamental nature of reality, particles, forces, even space-time itself, what if it was just an emergent phenomenon?
Right, not the fundamental layer at all.
Exactly. What if it all stemmed from something, well, deeper, something this paper calls coherence?
Coherence. And you might think, okay, things working together, being in phase.
Sort of, yeah, but on a completely cosmic scale.
That's right.
Well, let's unpack this a bit. Today, we're diving into a really fascinating paper. It's from Philip Lilien, titled Coherence, Quantization, and the Emergence of Fields, Eigenvalue Structures in the Universal Field Tensor. Now, for those of you really steeped in traditional physics, get ready, because this might feel like some serious mental gymnastics.
Definitely. Lillian's ideas, they kind of turn some of our core assumptions upside down.
It's not just another theory, is it? It feels more like a radical inversion of how we usually think about quantum field theory.
That's the perfect word, inversion. Our mission today, really, is to explore this, well, audacious idea Lilien puts forward, that coherence isn't just a property of systems.
But the actual substrate, the foundation.
Precisely, the foundational substrate from which all physical phenomena arise. So, forget spontaneous symmetry breaking.
Where the universe just kind of chooses a state.
Right. Instead, he proposes something called coherence selection. That's the real engine of emergence in this view.
And what's really mind-bending is how this changes familiar concepts. Like, you'll discover how particle mass isn't just sort of tacked on arbitrarily.
Or charge being just some label.
Exactly. And even spin isn't treated as a fundamental quantum postulate here. It's all seen as dynamic reductions of a continuous field.
Dynamic reductions. It really makes you step back and ask, okay, what does this actually mean for how we perceive the universe?
So let's dig into that core idea first.
Yeah.
Coherence as the primary fabric of reality. In conventional quantum field theory, quantization, well, things come in discrete chunks, like electron charge that's usually imposed on the fields, right? It's almost like a rule you add later.
Yeah, you kind of force it mathematically to match what we see. Lillian's work suggests, no, there's a much deeper causal structure actually producing that quantization.
That's the heart of it, isn't it?
It is. The fundamental starting point is this coherence primacy postulate. It basically says all quantized phenomena, everything discrete we observe, arises from these structured coherence interactions.
And coherence here isn't just waves lining up neatly.
Not at all. It's a much richer concept. A field state defined by its amplitude, its curvature, and something he calls resonance integrity.
Resonance integrity, like how well it holds a pattern.
Kind of like that. Imagine this perfect, unified state, maximum coherence. In that limit, all forces would be one. Unified.
Like a perfect symphony.
Exactly. And as that perfect coherence degrades, or maybe differentiates is a better word, that's when our familiar quantized structures pop out. The individual notes, the instruments of reality start appearing.
This is a new kind of emergence, not symmetry breaking, though.
Symmetry emergence through coherence selection. That's his term. So those standard gauge groups we talk about, U1 for electromagnetism, SU2 for the weak force, SU3 for the strong force.
They aren't fundamental things that just exist.
In this model, no. They're seen as specific threshold events, points you cross in this grand coherence cascade.
Okay, a cascade. And to describe this whole cascade, Lilien introduces the universal field tensor, the UFT.
Right. And if we stick with that music analogy for a second, think of the universe like music. It's not built note by note, right? It emerges through resonance thresholds, modal activation.
Oh, okay.
The UFT is like the complete infinite potential score for all possible music. Every potential note, every harmony, every rhythm, it encodes it all in this primordial coherence field, what he terms the omnilectic coherence field.
The omnilectic field. Fully coherent, infinite potential.
Exactly. Pure potentiality. What does that analogy bring up for you?
For me, it really highlights the elegance. That reality isn't assembled piece by piece, but it's sort of revealed, unfolded. It makes a complex idea feel more intuitive. And for that harmony, that potential to actually manifest as our physical reality, Lilien says specific notes or chords have to be activated.
Precisely. And that brings us to the four sort of foundational building blocks he identifies. Each one is like a distinct layer in this coherence emergence cascade.
Okay, what are they?
Right. First up, coherence thresholds. Think of these as critical levels, nonlinear phase transition points.
Like hitting a specific frequency.
Kind of like that, or a specific volume level you have to reach for a certain field or particle or symmetry structure to actually emerge. And importantly, they're quantized for each layer.
Okay, quantized thresholds. Got it. Examples.
Well, for instance, the electromagnetic field, that's the U1 symmetry, it emerges at a coherence threshold. Amplitude, he estimates, around A equals 1 over the square root of 137, related to the fine structure constant.
Right.
But the SU3, strong force, that needs a higher threshold, typically around A equals 1/3.
Right, so different points on the dial. Then there are coherence amplitudes. What's that?
Amplitude is simpler. It's just the local strength or density of coherence.
Yeah.
Think of it like a continuous dynamic field, sort of the overall volume knob in an area.
And that volume determines what can play.
Exactly. It determines which eigenmodes, which melodies can actually be activated.
Yeah.
If the amplitude goes above the threshold for a mode, bam, it can activate. If it falls below, the mode just stays latent, silent.
I like that analogy he uses. Amplitude is the fuel, and the threshold is the ignition point.
It's a good one. You need enough fuel and the spark.
Okay. Third building block.
Coherence eigenmodes. These are the actual stable structural resonance patterns allowed by the coherence field. Think standing waves, but they can be more complex, geometric, harmonic, even topological.
So these are the possible structures, the blueprints.
That's a great way to put it. Lilien calls them the ontological scaffolds of reality. They define what can be, the allowed patterns.
And finally,
coherence eigenvalues, often written as lambda. These are the specific quantized numerical values that get attached to an activated eigenmode.
so when a pattern is actually playing.
Right. The eigenvalue determines its intensity or its curvature or its coupling constant. Physically, these eigenvalues are what we measure as mass, charge, spin, field strength.
Ah, so the eigenvalue is like the visible shadow, as he puts it.
Exactly. It's the measurable aspect of that underlying resonance pattern. But it only shows up when the mode is active and the threshold conditions are met. They're the specific notes you actually hear.
Okay, so these four things, thresholds, amplitudes, eigenmodes, eigenvalues, they all have to work together.
Absolutely crucial. The dynamic interplay is key. Lilien's model says field emergence needs both enough local coherence amplitude and the right eigenmode structure lining up.
Is there like an equation for that?
Yeah, he proposes an activation criterion. AX times I must be greater than or equal to T mode.
So local amplitude A times the eigenmode structure has to meet or beat the threshold T for that mode.
You got it. That's the trigger for something to become manifest.
This all sounds like it builds into a larger structure. He calls it the coherence spectrum,
Yeah.
right?
Think of the coherence spectrum as the full continuum of all possible states within this universal field tensor, organized by amplitude. It's like the universe's master plan showing what appears when and under what conditions.
And it has distinct layers based on that amplitude.
Exactly. It starts at the very top, maximum coherence with the homoelectric field, amplitude A equals 1. Everything's fully coherent, pure potential, no individual structures yet.
Pure potential.
Yeah.
Then what happens as the amplitude drops?
Well, as that perfect coherence amplitude reduces slightly, you enter a layer he calls pre-manifestation. That's between roughly A0.33 and A1. Here you get protofields, symmetry precursors, like faint hints of structure.
Okay, precursors. And then?
Then, around A equals 1/3, bang! The SU3 strong force emerges. This is the force holding atomic nuclei together. It's characterized by color confinement, torsional modes.
Torsional, like twisting modes.
Yeah, geometric structures. Then drop the amplitude further down to about A equals 0.23, and you hit the SU2 weak force threshold. This is where isospin emerges, related to particle decay.
And then finally, the lowest amplitude one we mentioned.
Right, at A equals 1 over the square root of 137, you get the U1 electromagnetic field. This is where we see familiar things like phase curvature, and of course the fine structure constant pops out naturally from this threshold amplitude.
It's like the clearest, lowest note in this whole cosmic scale.
A good way to think of it. And below that, the spectrum continues down into post-reduction, where A is much, much less than 1. This leads towards full decoherence. The music fades into noise, essentially.
So it's a cascade down through these layers.
Exactly. He calls it the coherence layering cascade. And from this, he outlines a really interesting 6-stage emergence sequence. It describes the whole journey from pure potential to observable reality.
Okay, what are the steps?
It's quite logical, really.
Yes.
Step 1, latent vacuum coherence. That's the pure A1 potential. Nothing's happened yet.
It's just potential.
Step 2, amplitude amplification. The coherence field starts to gain some localized structure, some bumps or peaks in amplitude.
Okay, structure appears.
Step 3, threshold crossing. The local amplitude, AX, reaches or exceeds a specific threshold, T, that ignition point we talked about.
Spark.
Step 4, eigenmode activation. Once the threshold is crossed, specific patterns, those eigenmodes, the melodies start to resonate. They get switched on.
The blueprint becomes active.
Step 5, eigenvalue projection. This is where the numbers appear. Those quantized values, mass, charge, spin, emerge as measurable quantities associated with the activated mode.
The visible shadow.
And finally, step 6, field or particle realization. Observable physics appears. A stable proton, an electron, an electromagnetic wave. The concrete reality we experience.
Wow. It's like a complete recipe for cooking up reality from coherence.
It really is. And the significance of this layered model, this sequence, is huge. It suggests a single, unified mechanism behind everything.
So you could potentially derive things like mass hierarchies.
Yeah.
Why particles have the masses they do.
Exactly. Derive mass hierarchies from curvature eigenvalues, maybe coupling constants from the threshold amplitudes themselves, and even particle families from the different activation patterns. It's incredibly ambitious.
This sounds like it could potentially organize everything we see.
That's the goal, I think, from the quantum foam right up to potentially even complex systems.
Okay, this brings us to something that sounds really practical, almost like an engineer's tool. The Coherence Quantization Protocol, or CQP.
Right. The CQP is Lilien's proposed systematic method for actually deriving those physical observables, mass, charge, spin directly from the structure of this coherence field.
So instead of quantization being this thing you add on,
It's intrinsic. That's the key idea. Quantization isn't imposed. It arises naturally from the field's own dynamics.
how does it work? What's the core principle?
The core principle is that all this physical quantization comes from the interaction between the field modes, those eigenmodes and gradients, or changes, in the coherence field. It's expressed mathematically through a specific eigenvalue equation.
Yeah.
C hat acting on phi equals lambda times phi.
Okay, an eigenvalue equation, and the CQP is like a set of instructions.
Pretty much. It's laid out as a 6-step protocol, a step-by-step guide to calculate observables. You start by identifying the coherence amplitude in a region, figure out the active eigenmodes, solve the equation, and interpret the resulting eigenvalue, lambda, as a physical quantity.
It sounds like a recipe for reading the universe's own rulebook.
That's a good way to put it, and here's where it gets really interesting.
I'm ready.
The CQP isn't just descriptive. Lilien claims it can actually predict fundamental particle properties.
Predict, like calculate values from scratch.
That's the claim. He uses neutrino mass as a prime example.
Ah, the famously tricky neutrino masses. Okay, how?
So, using the CQP, he first assigns the neutrino a coherence amplitude. It's placed near the SU2 weak force threshold, so he estimates its amplitude, ANU, is somewhere between, say, 120 and 140. Pretty low coherence.
Okay, low amplitude. Then what?
Then he estimates its corresponding eigenvalue using a relationship he finds. He proposes lambda ANU is roughly 1 over ANU squared.
Inverse square. Okay, so if A is 120 to 140?
Lambda ANU comes out somewhere between 400 and 1600.
Right, a dimensionless number so far. How does that become mass?
He then applies a specific curvature mass relation. It's basically mu equals some constant, mu0 times 1 over lambda ANU. So mass is inversely proportional to the eigenvalue.
And mu0 is?
He estimates mu0 at about 3.73 keV based on other parts of the theory. Plug in the lambda values.
Okay, so 3.73 keV divided by 400 to 1600.
And he predicts a neutrino mass range of about 9.3 electron volts down to 2.3 electron volts.
And how does that compare?
That's the remarkable part. This range, derived purely from the coherence framework, actually matches the known experimental bounds for neutrino masses quite well, which is, well, it's pretty stunning if it holds up.
Wow. Okay, that is impressive. Is this inverse square relationship specific to neutrinos?
No, he suggests it's more general. This relation, lambda equals some constant k divided by ai squared, seems to hold across different scales.
Like for electromagnetism?
Exactly. For EM, the amplitude A is about 1 over root 137. Square that, invert it, and lambda is roughly 137, directly related to the fine structure constant alpha.
Okay.
And for the SU3 strong force, amplitude A is about 13. Square that, invert it, lambda comes out around 9, which connects to strong force properties.
So there seems to be a consistent mathematical pattern emerging from these coherence levels.
It certainly suggests a deep underlying consistency. And this predictive modeling aspect, it opens up some wild possibilities.
Like what? Predicting new things.
Potentially, yes. By looking for amplitude zones in this coherence spectrum that aren't currently associated with known particles or forces.
You could predict what should be there.
Maybe. Things like dark coherent states, perhaps related to dark matter or dark energy, or maybe neutrino-like condensates existing in space, or even residual fields beyond electromagnetism post-U1 fields. It's a totally new hunting ground.
A new way to look for the missing pieces of the universe.
Okay.
So, to describe how all these coherent structures interact, how they resonate and combine or reduce, Lilien introduces new math.
He does. A whole new algebraic framework called the coherence bracket algebra. It's designed to generalize the traditional Lie brackets you see in quantum mechanics.
Lie brackets are about how operators relate. How does this coherence bracket work?
He proposes it acts as a kind of coherence interference engine. The coherence bracket, written like phi GC, is this anti-symmetric form.
Anti-symmetric, meaning if you swap phi and phi, it flips the sign.
Right. And it basically encodes how two different coherence configurations, phi and phi, interfere with each other based on their gradients, their changes in space or time.
So it tells you if they resonate together or cancel out.
Exactly. It shows when two modes interact to generate a new state through resonance, or when their interaction leads to nothing, or decoherence.
And this has implications for things like entanglement. That's a notoriously weird quantum effect.
Hugely fascinating implications. This formalism offers a completely new way to model entanglement.
How so?
If the coherence bracket between two fields, say field A and field B, phi A, phi B, C, is not zero.
Then they're linked.
Then they're resonantly linked, coherence coupled, you could say. If the bracket is zero, they're independent, not entangled through this mechanism.
Wow, could it handle multiple entangled particles?
He suggests it extends to multi-field entanglement algebra. So you could potentially model the intricate coherence links between, say, quark fields, lepton fields, and the electromagnetic field all within one framework. It's a very different picture of entanglement.
Okay, new algebra. Does it lead to new symmetry groups too? We talked about U1, SU2, SU3.
It does. Building on the bracket algebra, he introduces the coherent symmetry group, or CSG.
CSG. How is it different from standard Lie groups?
It's a dynamic generalization. The revolutionary part is that its structure constants, the numbers that define how the group generators combine, aren't actually constant.
Wait, the structure constants aren't constant. How does that work?
They depend on the local coherence amplitude and the eigenvalue. They change as the coherence level changes.
Whoa, what does that allow?
It allows for smooth, continuous transitions between different gauge symmetries as the overall coherence reduces. Instead of sharp, distinct breaks between SU3, SU2, and U1, you get a fluid evolution.
So the CSG describes the emergence of those standard groups.
Exactly. It models gauge field emergence as a dynamic symmetry reduction tree, like a cascade starting from some very high-level symmetry generator, maybe related to gravity.
He calls it a hypergravity generator.
Yes, sumega. And as coherence reduces, this flows down, reducing via these coherence brackets, eventually yielding the generators for SU3, then SU2, and finally the U1 generators, theta, which gives us electromagnetism.
It's like watching the symmetries crystallize out of a fluid state.
That's a great visual. And here's another crucial link. Each generator in this coherent symmetry group interacts with an eigenmode through that coherence bracket we discussed.
And that interaction gives you the actual physical quantities?
Directly. The interaction of the U1 generator's theta yields electric charge. The SU2 generators, say, yield spin and chirality. The SU3 generators, say, give you color charge. And even the top-level hypergravity generator, sumega, is linked to mass.
So charge, spin, mass. They aren't just properties tacked onto particles. They're direct algebraic consequences of these coherence interactions and symmetry reductions.
That's the core idea, a fundamental derivation of all these conserved quantities from the underlying coherence structure.
Okay, this framework is really challenging some deep assumptions. The next one seems huge. Space-time itself, not fundamental.
Not fundamental. That's one of the most radical proposals here. Space-time is seen as an emergent structure.
How does that work? What does it emerge from?
It emerges from what Lilien calls the hypergravity field, HMNU. But this isn't a field in space-time like gravity usually is. It's presented as this underlying invariant zero-divergence coherence manifold.
A coherence manifold. So
Yeah.
space-time itself is a projection from this deeper coherence layer.
Precisely. This hypergravity field doesn't curve space-time in the usual sense. It projects space-time geometry, the metric, curvature, causality as a resonance effect of the coherence. My head hurts a little just saying that.
Mine too. So gravity, how does that fit in?
It gets a complete makeover. Space-time curvature emerges from gradients within this underlying coherence field. Points of high mass become coherence contraction nodes, regions where coherence is intensely localized.
So mass is concentrated coherence.
In a sense, yes. And gravity isn't an attractive force pulling things together. It's a structural modulation of this coherence field caused by these nodes.
Does this connect back to Einstein's equations at all?
Lilien suggests Einstein's field equation, the bedrock of general relativity, can be essentially recast. Instead of dmu equals tmu, it becomes something like hmu equals a function of coherence properties, phi, a, lambda. Hmu represents the coherent structured field that manifests as spacetime geometry and gravity.
Okay, that's a fundamental rewrite. And what about dimensions? Still 3 plus 1.
Not necessarily fixed. This is another wild part. Dimensions themselves are proposed to emerge through a kind of hyperfractal layering of these coherence modes.
Hyperfractal layering.
Yeah, where each layer corresponds roughly to a different gauge domain, U1, SU2, SU3. This architecture, he suggests, could naturally allow for dynamic or even fractional dimensions, unlike our usual fixed 4 dimensions.
Fractional dimensions.
Yeah.
Okay, my brain is officially stretched. This must change how we think about measurement too, right? The whole quantum measurement problem.
Absolutely. This leads directly to what he calls the Unified Measurement Principle, or UMP. It profoundly reinterprets observation.
How? What is quantization in this view?
Quantization itself, the fact that things appear discrete, is seen as coherence node locking. Imagine field interference patterns settling into a stable harmonic closure. That closure is the quantum state.
So measurement isn't an external observer poking a system.
No. Measurement is redefined as a universal resonance interaction between an observer field and a system field. It's coherence interacting with coherence.
And an observer isn't just a conscious being.
Not at all. An observer is any entity, could be a planet, an atom, an electron, anything that participates in and causes coherence reduction or node locking. It's a universal process.
Okay. The implications of that must be huge. What about wave function collapse?
Reinterpreted. Wave function collapse isn't a mysterious jump, it's simply resonance fixation. The system settles into one stable coherence pattern due to the interaction.
And entanglement.
Entanglement becomes coherence sharing between systems, maintained until decoherence breaks the shared resonance.
And probability, like Born's rule.
Probability reflects unresolved resonance overlap. The likelihood of measuring a state depends on the degree of resonant overlap between the observer field and that particular state mode in the system field.
This sounds like it could lead to different kinds of measurement.
That's one implication. Maybe designing non-collapse measurement devices that can probe a system by resonating with it very gently without forcing a full node lock. Or it could even touch on ideas of observer-dependent realities, depending on the coherent structure of the observer. It fundamentally changes the game.
So let's try to bring this all together. How does this framework give us a unified view of particle physics? What are particles?
Right. In this picture, particles aren't fundamental point-like bits. Fermions matter particles like electrons. Quarks are viewed as topological solitons. Stable twists or knots in these coherence chains.
Like persistent patterns? And bosons, force carriers like photons.
Bosons are seen as harmonic transmission quanta. Vibrations or resonance packets traveling between those fermion coherence nodes, they carry the interaction.
And mass. We touched on it, but how does it arise specifically?
Mass arises from coherence contraction. There's a formula proposed. M equals some coherence eigenvalue lambda c divided by the rate of coherence dissipation, DID. It relates mass to how tightly coherence is bound and how quickly it might leak away.
So inertial mass resisting acceleration.
That reflects the energy cost to disturb one of these stable coherence nodes, how much effort it takes to disrupt its resonance pattern.
And the gauge fields EM, weak, strong.
They're viewed as the coherence channels associated with those symmetry reductions from the higher hypersymmetry states. Each one corresponds to a different dimensional layer or type of coherence transmission. U1 for phase coherence, SU2 for chirality spin coherence, SU3 for torsional color coherence.
It all sounds incredibly unified, everything flowing from one source.
That's the beauty of it conceptually. All fields, all forces, ultimately reduce from a single, unified, hypersymmetric resonance field. The distinctions we see are just results of different cascade depths, how far down the coherence spectrum you are, and the specific interference structures that form.
A single source manifesting in all this diversity.
Exactly. And what's really compelling is how this framework seems to naturally accommodate things that are tricky for the standard model.
Like what? We mentioned neutrino mass.
Right. Neutrino mass finds a natural explanation via minimal coherence dissipation. They're very weakly bound nodes. Dark matter. Could it be dark coherence condensates, structures that have coherence but don't interact electromagnetically, making them invisible to us decohered observers operating in the U1 band?
So dark matter isn't necessarily exotic particles, but just off-spectrum coherent.
That's one possibility offered here. And hitting sectors in physics, maybe they're just orthogonal coherence projections, resonances happening in dimensions or modes that are completely outside our phase band of observation.
All explained without needing lots of new particles or extra dimensions tacked on.
Exactly. It aims for unification through the properties of coherence itself. It really represents a potential paradigm shift, moving away from thinking about disjoint forces and particles towards a unified, underlying ontological geometry. Reality as structured resonance.
It's a lot to take in.
Indeed. We've definitely gone through a truly groundbreaking framework today. This idea that coherence isn't just in things, but is the primary fundamental principle that gives rise to all physical structures.
Yeah, from the smallest quantized particles right up to the structure of space-time itself, all viewed as manifestations of structured resonance.
It's a profound shift.
This deep dive, I hope it's offered you, the listener, a completely new lens to view reality through. A reality where matter is resonance, forces are gradients of coherence, and space-time itself is like an echo of this deeper layer.
It's almost like if the universe is a symphony, we've mostly been listening to the melody and percussion, and Lilien is saying, hey, listen to the deep harmonic structure underneath it all.
That's a great way to put it. And Lilien doesn't just stop at the theory, does he? He actually proposes experimental ways to test this.
Oh yeah, some really incredible potential strategies. Imagine being able to detect tiny shifts in these coherence eigenvalues using incredibly sensitive interferometers. That could be direct evidence.
Or what about those non-collapse quantum sensors, based on the unified measurement principle?
Right, devices that could probe a quantum system by resonating with it gently without forcing it into a single state. That would be revolutionary for quantum computing and sensing.
He even suggests trying to modulate inertial mass using structured, coherent electromagnetic fields. Could we actually change an object's inertia?
That's definitely out there, but it follows logically from the idea of mass as a coherence node. And could we eventually detect those neutrino condensates he theorized about, maybe hiding in galactic halos and explaining dark matter?
Or even simulate dimensional fluctuations in a lab setting? It opens up so many questions.
It really does suggest a universe governed by something akin to harmonic intelligence.
There's that quote from Lilien you mentioned.
Yes, at the origin of all things is not particle or point, but resonance-structured, recursive, intelligent. Through coherence, the infinite whispers itself into the visible.
The infinite whispers itself into the visible. That's quite poetic.
It captures the essence of it, I think.
So here's a final thought to leave you with. If reality truly is this coherence engine, constantly generating appearances from what Lilien calls infinite intelligence, how might that fundamental shift in understanding reshape our approach to other complex fields? Like artificial intelligence, maybe? Or even our understanding of the nature of consciousness itself?
That's a deep one to ponder. If the universe operates on resonant intelligence, what does that imply about our own intelligence, or the kind we're trying to build?
Something to think about.